So forward search simply means you start with a feature. Let's see if I can draw a picture. So in forward search, you simply start with a feature of your in features. You look at all of your features in isolation. Let's imagine we have 5 features. And I say, well, I'm just going to pass you the first feature. Pass the first feature to the learning algorithm. I get a score. Then the second feature, then the third feature, then the fourth feature to the fifth feature. And whichever one of those features is best, I keep. So let's say it's the first one over here. So now I keep the first feature. And then I say, well, now that I'm given the first feature, let's look at each of the remaining features and see if I add them, which one does best. So I end up with 1, 2, 3, 4, 5. I pick the best one, and let's say that turns out to be feature 1. And then I look at feature 1 in combination with 2, in combination with 3, in combination with 4, and in combination with 5. And whichever one has the highest score, that's the one I move forward. And so that would be, let's say, in this case, it worked out to be feature 5. And now that I have these 2 features, I pick a third feature of the ones that are remaining, 2, 3, and 4. And whichever one of those, in combination with 1 and 5, I add next. And let's just say that turns out to be feature 3. But it turns out the error, or the score that I get for adding the third feature to 1 and 5, isn't significantly better than just having 1 and 5. And so I stop here and say that's the subset of features that I would take. Does that make sense?
Yeah, that seems like a really neat idea, and I could see that as being a kind of efficient polynomial way of searching this space. Though, could I think of it as a kind of hill climbing, though, where my neighborhood relation is basically adding one more feature?
Sure, absolutely. And if it's only adding one more feature, that's exactly what you're doing. You are doing a kind of hill climbing. So in fact, the alternative, or the sort of complement to forward search, is backward search. And backward search is, I think by the way you describe it, is exactly another kind of hill climbing, where here we start out with all of the features, and you say, well, which one can I eliminate? So I try 1, 2, 3, 4. I try 1, 2, 3, 5. I try 1, 2, 4, 5. I try 2, 3, 4, 5. And whichever 4 work out best are the ones that I keep in the second round. And let's just say that turns out to be 1, 2, 3, and 5. And then I see, well, of the remaining 4, which one can I eliminate and still have the best score? And I keep doing that until I get down to a subset that still does pretty well. So let's say I get to this case, and it turns out, you know what, 1, 2, and 5 do just almost as well as 1, 2, 3, and 5. But once I go to just 1 and 5, it does much worse, and so I'm going to stick with that. So here, you're right. I like the way you describe this, Michael, as hill climbing. Here I'm doing hill climbing, except my neighborhood is removing a single point instead of adding a single point.
Yeah, that's cool. It's for some reason reminding me of like making a team. Like I could imagine tryouts where you put everybody on the field and you have them play, and whoever's helping the least, you kick them off the team. So that's kind of the backward case. We just keep kicking people out until we have the team we want. And then the forward case is kind of like the dream team model, where you start off saying, I got nobody, let's take the best person around, add that person to my team, and keep doing that until we have a full set of players.
Okay, so does that all make sense?
Yes.
Okay, so just to summarize, filtering algorithms don't while they can take advantage of a label, they don't really care about the learner. And so you have to come up with criteria that all probably make sense, like the ones you came up with: information gain, entropy, variance, and you can tell stories for why all of these make sense. This, by the way, is where your domain knowledge comes in. It's the choice of the criterion or the optimization function that you're using. But they have a problem in that they don't actually take advantage of the bias of the learner, where wrapping definitely takes advantage of the bias of the learner. And then you just simply have a question of how to deal with the exponential search problem by doing, I think in all of these cases, what looks a lot like hill climbing. And just have different methods for thinking about how to do the hill climbing. Do you add variables or remove variables, or do you do some kind of random search? But ultimately, in both cases, you have some function you're trying to optimize over.